Hello guys, yesterday I introduced you to Raptor, which is a really cool way of doing retrieval augmented generation. In this video, I'm going to show you how you can use this Raptor with open source models for free. Yesterday we saw how to install Raptor and then how to get it integrated with OpenAI's model, both the GPT-4 model for question answering and for embedding model we use the GPT's own model. But in this video, we will be using both open source models for inference and also for the embedding. Before I take you to this Raptor and we get it installed, let's have a quick overview of what exactly this Raptor is. You can find more detail on it in my previous video and I will drop the link to it in video's description, or you can just search it on my channel. I just did it yesterday. The thing is that these retrieval augmented models, they can better adapt to changes in world state and incorporate long tail knowledge. But the problem with most existing model is that they retrieve only short contiguous chunks from a retrieved corpus, limiting holistic understanding of overall document context. That is where this Raptor comes into play. So we will be installing it locally and then we will also use it with our own custom data to do the RAG. Before I go further, let me introduce you to our friends at Mast Compute, who have provided a GPU of 48 GB of VRAM, which is NVIDIA RTX A6000, and the VM for this video. So really huge thank you to them and huge shout out. If you are looking to rent a GPU on affordable prices with very high quality, which I have been using in my videos these days, I would highly recommend them. I will drop the link to their website and a discount coupon code in video description. If you use that, you will get 50% off discount on their already very discounted prices. Always available, no lock-in, very affordable. So coming back to this Raptor, let me give you a very quick overview of this architecture, which is actually quite interesting. So you see what is happening here is that building on the idea that long text often present subtopics and hierarchical structures, Raptor addresses the issue of semantic depth and connection in reading by building a recursive tree structure that balances broader thematic comprehension with granular details, and that allows the nodes to be grouped based on semantic similarity, not just in order the text. So in this diagram, you can see the tree construction process where Raptor is recursively clustering chunks of text based on their vector embeddings and generates text summaries of those clusters. And that constructs a tree from the bottom up. Nodes clustered together are siblings. A parent node contains a text summary of that cluster. So that is what is all there happening. Now let's go to our local system and then let's see how this thing gets installed. This is my local Ubuntu system where I'm using Ubuntu 22.04 as a VM, and my GPU card is this NVIDIA RTX 6000, as you can see here, and both of them have been very generously sponsored by Mast Compute. Let me clear the screen. Now in the next step, you would need to create a Conda environment, and then we will see how to install Raptor, and then we will use the local models. Now I already have the Raptor repository and also my Conda environment, but just to show you the whole code, let me take you to my VS Code and then we will simply implement it in our local system. It's a similar thing. It will just make it a bit easier for you to read what exactly is happening in the code. So let me take you to my VS Code and I will walk you through. Okay, so this is what we need to do. First up, if you are doing it now and if you didn't follow my previous video, first up go and create this Conda environment. And if you don't know how to install Conda, I will highly suggest just search my channel and you will find a video on Conda. It keeps everything simple and separate from your local installation. So first create the Conda environment, and then we just need to activate the Conda environment by simply saying Conda activate Raptor and we should be good. So we will do that because I already have the Conda environment, so I'm just going to activate shortly. Then git clone the repo of Raptor, cd to that repo, install all the requirements, and then install sentence transformer. It is not present in their repo, so you must install this, otherwise you will get the errors. Okay, then import the OS, and because it's an OpenAI's API compatible API, so we have to specify this environment variable, but just set it to not applicable. Once that's done, import all of these libraries from Raptor, which use tokenizer, model, and all that stuff. Okay, so once that's done, we have defined some of the classes. For the purpose of this video, I'm just using the Gemma model, the Google's Gemma model. You can use any model of your choice from Hugging Face. So all this is doing, if you look closely, it is just defining that auto tokenizer of Gemma model, throwing it into the pipeline for text generation with these hyperparameters, and then setting the device to CUDA, because I am using massed compute sponsored GPU. If you have a CPU, then it will select the CPU, but I won't recommend using CPU for this purpose. Okay, but you can try out on CPU too if you like. And then this simple summarize function, which is giving a prompt template that just write a summary of it, and then applying it chat template on top of it, which we have just defined user and assistant one. And then we are generating the output from the model, and you have seen me using these statements on Python interpreter. So for this one, they have just put it in this file, and these are the values which are just controlling the output of the model, the randomness, and how much it selects from the top probabilities. Once that's done, just return the summary out of it. And then similarly, that was for text generation summarization. This is for question answering if you want to do that. And then similar function, just flip the prompt template. Just instead of telling it to summarize it, we are just telling it to do question answering. From there, this is the tokenizer, throw into the pipeline with same hyperparameter. You can tinker with it, because you see this is more creative in terms of question answering. If you go up, that is also very creative. Okay, that is done. And then get the sentence transformer, and this is where we specify our embedding model. And in this one, sentence transformers, multi-QA MPNet is being used. You can use your own if you like. There are heaps of embedding models out there, so whatever you like you can use there. And this is all it is doing. And then we are just defining our retrieval augmentation config with summarization tool this, which we have already defined, our Gemma model. And then we are defining the embedding model, which we already have defined above. So this is the rack config we need to give. We just calling it rack retrieval augmented configuration, and then we are instantiating that retrieval augmentation with this config. This is the sample file which I'm using from their GitHub repo, and then you can add more files if you like, but we are just adding this one file. Once you have added it, we are just giving it a question. You can just give it any question you like, and then get the answer and print the answer. That is all there is to it. So you see how easy it is to replace the values here. You can have your own model. You can have your own model for embedding. You can have your own file. You can have your own question. I will drop all this code in my blog, and I will drop the link to it in video description. You can also find it on their GitHub repo, but I will just put it there with all these prerequisites which you would need in one place. Okay, so that is all what we are going to use. So let me now take you back to my terminal. So you see I'm already in the Raptor directory because I already have cloned it. Let me clear the screen. Let me activate that Raptor environment which we have created. You see in the parentheses, that is good. I already have installed all the prerequisites, and just to refresh your memory, let me show you what I'm saying here. This is my VS Code. I already have created the environment. We just activated it. I already have cloned the repo. I showed you that I'm in the Raptor directory. I already have installed both of these. Okay, now what I have done is the code which I have showed you, I have just copied all the code without changing anything, and I have put it in the terminal. I'll quickly show you. If I do ls-ltr, this last file local rag is what I have done. So let me open it with a vi editor. You see, so I have just put it all the code in this file instead of one by one putting it in the Python interpreter. It's easier to put it here. and I don't have to worry about indentation and stuff. So that is done. Let me clear the screen and I am going to run it. So first what happens is it is going to download the models, both embedding and the other one, Gemma one, and then it is going to do the RAG. So first up, if you're running it first time, it is going to take a bit of a time. So just bear with it. You see it has loaded that FIAS library with AVX2 support for the vector store. It has loaded the Gemma model. It is yep, you see both of the shards have been loaded, and it has uses the CUDA as a now doing the batches on my file. It has created 35 leaf embeddings. It has built all the nodes. Depending upon your GPU, it is going to take a bit of a time. And now it is summarizing that file. And then it is bringing in the batches of that summarized file. And larger your file is, the more time it is going to take. Mine is, I think it's not that big. So let's wait for it to finish. I will let it run just to see, just to show you the steps of it. But it shouldn't take too long because the file and the question is very simple. There you go. So it has collapsed the tree, and then there you go. So it didn't find the answer in that one. So when it doesn't find it, it is going to give you this answer. Otherwise, it is going to give you the answer. And then you see that this is the tree retrieval config we had given it to it, and it has uh, just told us what it did throughout the process. So this is how you can do the retrieval augmented generation with local models easily and quickly without worrying about any API throttling, API calls and stuff. So that's it guys. I hope that you enjoyed it. But just first up, I wanted to also tell you that I have used it with few other models too, like Mistral and Mixtral. But in my humble opinion, right now, it works best with OpenAI's model. I don't know why, but I have to say that I really love open source models. But I think um, if you go to this video, the other one, the new RAG method with richer context, where I have used it with OpenAI, the response was way more quicker, and the quality was much higher. But anyway, so I think still I believe we can use these open source models. They are good enough. That's it guys. I hope that you enjoyed it. Let me know what you think. If you like the content, please consider subscribing to the channel, and if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.